All right, red elk runs with a purely horizontal velocity. Okay, so let's see. So he's running off a cliff. Whoops. I feel like I was... All right, so let's see. 8.5 meters. So when it says 8.5 meters from the base, that's this distance. All right, so he's going to land out here. 8.5 meters from the base. So that's a horizontal distance. And it's 1.20 seconds that he's in the air. Okay. I think you know this and this. We always know this. Oh, what's it doing? It won't let me draw. Okay, hold on. Escape. Let's do pen. There we go. You always know this. We always know this, so you're going to know this guy. Okay, we know this guy. We always know that for these types of for cliff problems, right? Let's see. Yeah, and that's it. I feel like those are the things we know. Okay, so just pause for a moment if you would and see if you can fill in that stuff. Okay? All right, so 8.5 meters, that's your horizontal distance, right? The acceleration here is 0. This is negative 9.8. This guy's 0, right? And then the time is 1.2 seconds. And then you also know this time as well. Okay. So now we can just fill in the rest of it. So let's look at the vertical. Right. So for vertical, I'm going to find x. Let me see. I'm going to use no VF. So x is VIT plus 1/2 AT squared. So it's 0 because the initial velocity is 0, right? Plus 1/2 negative 9.8 times t squared. So that's 1.2. Don't forget to square it, right? All right. So 0.5 times 9.8 times 1.2 squared is negative 7.056. Okay. And that's meters of distance, right? All right, let's see. In the vertical direction as well, let's find the final velocity. V final is V initial plus AT. So that's going to be 0 plus negative 9.8 times 1.2. All right, so negative 9.8 times 1.2. This one's a little easier to figure out that it's negative, like that's negative 11.76. It just comes out, right? Assuming that you get that this is negative, right? All right, and then on our horizontal side, okay, let's ignore this. Can I get the eraser? Will it give me an eraser? Oh, it won't give me an eraser. Okay. All right. So for the horizontal side, we are going to go. We are going to just do the only thing we ever do, by the way, is just a triangle problem, right? It's like, okay, so x and v and t, right? So we're trying to find v. V is going to be x divided by t, okay? So v is 8.5 divided by 1.20. Okay, so 8.5 divided by 1.2 is 7.083. And there's a lot of 3's. And that's both of these. These guys are always the same because it doesn't change. There's no way for it to change. So once you've filled this in, now we can answer the questions, right? So let's look at the questions it asks. All right, I'm looking at the questions is what I'm doing. Okay, how high is the cliff? Well, the height of the cliff, notice that that's our vertical displacement, but I'm going to say that it's 7.06 meters tall. Now, I understand that it's a negative number, but that just means to get from the top to the bottom, you go down 7.06. But I feel like the best answer to that is that it's 7.06 meters tall. Okay, we got that right. What was the horizontal velocity? Well, the horizontal velocity is this guy here, right? Okay, this was our height of our cliff, right? So B, we're going to use that guy, right? So that is 7.08. And that is our meters per second. That's our horizontal velocity, right? And then let's see. C says, what is the final vertical velocity? That's this guy here. 11.76 meters per second down, right? make it negative. Don't forget to make it negative, or you'll lose it. You'll lose a half a point. Okay, and then the final question is draw a picture of its velocity of impact. So just pause here for a moment because I'm going to erase all of this. Okay, here it comes. Boom, there it is. All right, so remember that the velocity was 7.083, like that, and then this way it was down. So remember, when you draw it, draw these guys tip to tail. So draw the x, and from the tip of the x, draw the y. Right, and then the velocity is this guy. Make sure that these guys are arrows. Let's find that angle there, right? So theta is the inverse tan of 11.76 over 7.083. Don't put the minus signs in because we don't want a negative angle. Okay. Divided by 7.08. Lots of threes. All right, here we go. That's 58.9 degrees. So that's 58.9 degrees. Did I get that right? Ooh, I did. All right, and then we want to get the magnitude of the vector, which, by the way, is also the speed. Right, and that's going to be the square root of 7.083 squared plus 11.76 squared. Again, don't put the minus signs in here. There's an even better reason than this case, and that's because your TI calculator will give you an error if you do that. Whoops, I did times instead of plus. All right, 13.7 is what I'm getting. So this would be the speed. That's the speed it's going, right? If we wanted to make it a vector, we could say that it's 13.7 meters per second at a direction of 58.9 degrees below horizontal, right? We could also write it, by the way, if they just say write it as a vector, they don't give you specifications. You could also say that it's 7.08 meters per second in the x direction plus negative 11.8 meters per second in the y direction, right? But this is what it's asking you to do on the Quizlet, so be sure you do that. Make sure you use arrows, right? Be sure to label the angle. Make sure you label the hypotenuse, okay? Happy